For decades, environmental toxicology has categorized fine particulate matter and ozone as cardiopulmonary threats, pollutants that drive asthma, chronic obstructive pulmonary disease, and heart disease. However, data from environmental neuroscience identifies ambient air pollution as a direct-acting neurotoxin, placing the central nervous system at the center of the risk profile. This challenges the traditional assumption that the lungs effectively filter the blood and that the blood-brain barrier acts as an impenetrable shield against environmental particulates. By tracing the biological evidence, we can map an unbroken chain of causality from the inhalation of traffic-related soot to a statistically significant spike in violent crime. This cascade occurs in 3 stages: a physical breach of the central nervous system, an alteration of the body's stress architecture, and a steepening of the behavioral metric known as temporal discounting. The evidence reveals clean air is a biological prerequisite for executive function and societal behavioral stability. The brain is an immune-privileged environment. Ordinarily, it is shielded from the foreign bodies and pathogens that circulate through the rest of the body. But PM2.5 and ultrafine particles subvert these defenses through 2 distinct physiological routes. First, the direct olfactory pathway. Inhaled particles deposit in the nasal cavity, transporting directly into the olfactory bulb. Second, the indirect alveolar blood pathway. Particles penetrate the lungs, triggering immune markers that circulate to the brain, degrading the blood-brain barrier so neurotoxicants penetrate. Air pollution co-opts the body's immune response, using the systemic inflammatory signals from the lungs to bypass the brain's internal defenses. Once inside the brain, these toxins encounter microglia, the resident immune sentinels but ordinarily survey the neural microenvironment for cellular debris. Nanoparticles binding to microglial TLR4 receptors transform the cell into an aggressive, amoeboid phenotype, flooding local neural tissue with reactive oxygen species. The brain interprets this localized oxidative stress as a severe, life-threatening homeostatic emergency. This perceived threat hyperactivates the HPA and SAN stress networks, forcing adrenal glands to release cortisol and epinephrine. A Shanghai double-blind trial tested this, alternating real and sham air purifiers in student dorms. During high-pollution phases, students showed statistically significant spikes in these stress hormones. Chronic air pollution maintains the human body in a persistent chemically induced state of fight or flight, functioning as a systemic stressor that operates independently of any social or physical threat. This unremitting hypersecretion of stress hormones imposes a massive allostatic load, the cumulative physiological wear and tear on biological systems. The direct physical consequence of this massive load is the visible structural thinning and degradation of the prefrontal cortex. This region of the brain is the epicenter of inhibitory control, working memory, and the ability to plan for the future. As the prefrontal cortex declines, hyperbolic temporal discounting emerges. Air pollution physically rewires the brain's reward circuitry, destroying the biological capacity to delay gratification and regulate impulses. When an entire population experiences this systemic prefrontal degradation, it creates a quantifiable geographic anomaly. By impairing inhibitory control, air pollution lowers the psychological threshold for reactive violence and aggression. To prove this causal link, economists analyzed 11 years of crime data in Chicago, using wind direction as a natural experiment to isolate pollution from socioeconomic factors. On days when the wind carried traffic pollution directly into a neighborhood, incidents of violent assaults increased significantly on the downwind side of the interstate. Crucially, there was no increase in nonviolent property crimes. This suggests the pollution specifically triggers raw, impulsive aggression, rather than crimes driven by economic desperation. These localized spikes in violence are the predictable neurotoxic endpoints of degraded local air quality. This neurocognitive burden is not distributed equally. It is concentrated in specific neighborhoods by historical urban planning and environmental injustice. 20th century exclusionary zoning and redlining systematically placed marginalized communities adjacent to arterial highways and industrial zones. This legacy trapped populations in multi-pollutant focus spots. In New York, modern community monitoring shows inescapably high levels of black carbon and particulate matter in dense residential blocks directly bordering major corridors like the I-95. These populations face a continuous neurotoxic assault that physically compounds the pre-existing psychological stress of poverty. This creates a sustainability trap. Because pollution-induced temporal discounting biases an individual toward immediate convenience, it becomes biologically harder to value the delayed long-term rewards of environmental abatement. The resulting inability to value future outcomes creates a neurotoxic feedback loop that limits a community's capacity to advocate for its own recovery. Aggressive carbon abatement is the mandatory biological infrastructure required to preserve executive function, behavioral stability, and societal equity.